Hey everyone. So this video is continuing on from the previous series for CTK 460 to work kind of as a linear, supplement for the class. So if you're in CTK 460 in fall 2022, great. This will be, part of your curriculum. But if you're watching this in the future, unless something drastically changes in Unity, what you're seeing is probably also really valid and relevant. So if you're following this through, it should be just fine. This video is kind of opening up into a new area for us. We're going to start talking about the sort of like rendering and visual side of Unity, and there's going to be quite a bit of data to kind of get your head wrapped around. So I'm going to do the best I can. I am going to link, if you're again in the 460 class, I'm going to link in your assignment for next week a lot of other materials to look at and just things to read if you want to dive more deeply into these materials. That's great, especially if you're a visual person, if you're interested in modeling and all those sorts of things, graphic design, stuff like that. Because this is probably right up your alley. If you're more of a coding-based person or a audio-based person, it's totally fine. Like you can do a lot of the stuff at the surface level. I just want you to be aware, sort of what we're talking about and the different terminology and how things are classified and, the sort of work in the engine so that if you want to do something in the future, you know where to look and you know the language to use, but also it's sort of, enough about the engine not to hurt yourself or enough what to Google, to know what to Google, right, if you have a question. So that's sort of the idea. If you feel overwhelmed, don't worry. We will go over this again in class and work through these concepts sort of over and over again. But I'm going to lay a lot of stuff on you today, just kind of working through concepts. Great. So to that end, I'm going to pull up a website here. And hopefully you guys can see this. If you're having trouble reading anything on the videos, just let me know. I'm assuming it looks okay because I haven't heard any feedback with things being too small or anything like that. But it should be fine, hopefully. If I haven't heard anything, then it's probably fine. So anyways, what we're going to talk about is, like I said, the rendering side or the visual side of the engine. And to do that and get to the point where we're going to start making things look differently, your objects look differently, in your builds in the games, we sort of have to back up and think more broadly and holistically about what we're actually doing and what these objects are. So up to this point, I've talked about, you can see over here on the right, this is the engine, sort of behind this website. We've talked about these colors, right? So sort of, we're just whipping through things like, okay, blue is relating to the rendering engine or the visuals. Green is going to be, sort of the physics stuff. Yellow, orange is audio. It's all categorized, right? Each one of those things is profoundly deep, and there's a lot that goes into that. And that's no different here. We're backing way up and we're looking at a lot of different components here in visuals, sort of rendering and like how this all works at a fundamental level. And if this is, like I said, if this is your wheelhouse and sort of your background, then great. If it's not, just kind of follow along and know that you just need a surface level understanding. And that's going to be okay, right? For long term, you'll be able to get stuff moving. Okay, so sort of backing up, we have these things called meshes. I've mentioned these in class. The mesh, as you see here, is a collection of data that describes a shape. In Unity, meshes are used in the following ways, right? So in graphics, you can use meshes together with materials, which is what we'll talk about next, to show sort of what the GPU should be rendering. Okay, so this is not CPU, like the processor necessarily, but just like telling the GPU, the graphics processing unit, like what visually should be rendered in the scene. And that as a concept is really important so that you know that that meshes fundamentally, right, are being pushed to your GPU and that every mesh you have needs to be rendered by the GPU, right? So as we talk optimization, if you're bottlenecking your GPU, right, then you know that those are the sorts of things you want to be approaching. Like, okay, maybe I have too many meshes in my scene. How can I optimize that? And there are lots of ways to do that. And then this other one too, underneath this is really important because we mentioned this with physics, right? In physics, you can use a mesh to determine the shape of a collider. And that's over here again, this is a box collider, and the things I have highlighted here is my little table, right? So I have this mesh, which is a cube, right? And then I've deformed it, I've stretched it to make it look like this sort of rectangular table thing. And it has around it by default a box collider that is sort of attached to the cube. And then the previous videos in the class, I've talked about how that's like, it's like a physical skin, right? It's like it's the outside of it. We're using the mesh to determine where that collision should be determined, where it should happen, right? Which makes sense, right? You pick up an object in a game or in an experience, right? You want it to have physics and you want the skin of it to feel like real life, right? If you pick up an apple, the outside of it is skinned. So that's the idea. There are many other types of meshes. Most importantly, the one for VR that will come, we will see is called a skinned mesh, and there'll be these things over here, like in your inspector. There'll be stuff called like a skinned mesh renderer, and these are used for like hand tracking. So they're deformable meshes, so meshes you can bend, right, like your fingers. And that's all good. Like, well, as they come up, just know that that's like a subclassification of what we're talking about here today. Great. That's where we can stop with meshes. I want you to know what they are visually. Again, like everything in this class, this is part of a pipeline, that is part of a career. If you're really into 3D modeling and sort of visual component, read this stuff. Like, please, 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 like read more and push me if something doesn't make sense, or you want more material, or you need more, you feel like you're not quite understanding something. Like that's absolutely what I want you to be doing, okay? And how I can add to the value that you can't get from a normal like tutorial or video, right? Okay, so those are meshes, right? Sort of the outside of the object. It's the general shape, right? They're linked to the idea of a model, right? If you create a model, then that thing will import with a mesh that is more or less the shape that you've created. Okay, the next one we want to talk about is materials. So materials are a proprietary file format. So if you've used another rendering software, something like Blender or 3ds Max or something, you've probably dealt with material files before. If you haven't, it's cool. You're like me, right? As an audio person, I had no background in this whatsoever. What this is, so you can see here, and I'll link these in the description of this video if you just want to click through and read this stuff too. To draw something in Unity, right? You must provide information that describes the shape, it's like the mesh, right? And information that describes the appearance of its surface. You use meshes to describe shapes and materials to describe the appearance of the surfaces. Materials and shaders are closely linked. You always use materials with shaders. So we haven't talked about a shader yet, but that's important. I talk about it this way because shaders, as you'll see, become this like black hole of just insanity. They're really cool, but they can get very, very confusing. Think of it like this, right? You have to put a material on an object in Unity in order to change the appearance of its texture, which we're talking about in a second. Do you want it to look like a tree? Do you want it to look like a ball? Do you want it to look like whatever, right? If you don't do that, it's going to have this. It's going to look like this white kind of thing, and it says default material. In fact, if you watch the previous videos, right, I was really quickly just like throwing in materials because I talked about not being able to see the objects in VR. It's like really white and everything's bright, and you want to have contrasting colors at least. And that's what I did here. I created a material, right? This thing here, and I made this material red. It changed the component, right? Changed the albedo color of it in order to make this ball red. All that is a material. And that material, again, if we look back here, looks like this in Unity in this capacity. You see all these exposed different parameters and things to play with. It's just there so that you can pull and mess with the sliders that are going to do different things, depending upon what you want to do with the visual appearance of this ball. What's important at this point, right, before we kind of dive more deeply into it, is to know that this thing is necessary in order to change the visual appearance of the object. It's a marriage between the mesh renderer, which is actually the sphere, right, as a concept, and the physical, sort of outside collider, and then the visual renderer, and that's this, the mesh renderer, which takes in the component of a material. Okay. I mentioned a word in there, which was texture. And texture, if you've done any like work in like Photoshop or something like that, you've probably played with textures. Textures are the detail, right? So here, normally the mesh geometry of an object gives a rough approximation of the shape, while most of the fine detail is supplied by textures. A texture is just a standard bitmap image that is applied over the mesh surface. Okay, a texture can be, it says bitmap, it could be any file format, JPEGs, PNGs. There's like benefits to using one file over another. We talk about that, like optimization at some point. But what's important to know is you could bring in literally anything, any kind of picture, and then you can apply that picture as a texture to an object in Unity. Okay, and then this is how you get stuff like this. This is a cylinder, right? This is a primitive that has just tree bark applied to it, and that tree bark, right, is working with the material in order to create the visual appearance that it looks like it's bark, right? To put it on the object. Okay, the third component here. So we have meshes, right? Are the object, right? Then you have to put a material on it. That material can take in a parameter or like a thing, right? Which is a texture. But how do materials work, right? Like what is governing them? They're not magic, right? They're not, right? They're the way that they work is by using things called shaders. So shaders are like a whole universe, okay? And this is the first time, well, not the first time, I've probably said this in the class before, where I get way out of my depth with shaders. Like this is like a whole thing, right? If you are interested in technical art, like say you're an artist, graphic artist, taking 460 or just that's your thing, right? Shaders could be a really important thing for you to get comfortable with. They're written in code, but they can also be written with something called shader graph, which is referenced here. We don't have shader graph enabled in our version of Unity at this point in 460, but we can enable it for you if you want to, which is a node-based graph system to build shaders. Or if they're written in CG or HLSL, these languages that were created by like NVIDIA and other companies. Anyways, what do shaders do, right? They are the code that is telling Unity how to interface with your graphics card, right? And on the Quest, it's an onboard thing in the system on a chip, but it could also be your graphics card in your PC or Mac or whatever, right? They're telling Unity how to interface with that, what these different textures and things are doing. Should that thing be transparent? Should it be reflective? Should it be, whatever, right? There's so much magic you can do. For instance, I was talking to a student in class about this, about the idea of water, right? In a game, water up to this point is, there's some instances of this actually happening, but at this point, it's almost always prohibitively expensive to render as water, right? So it's not like ripples of water or droplets of water that you're seeing in a game, because it'd be insane, right? If you think about all like rendering all the physics of like the water interacting and stuff. I say that with a caveat because there are like really good fluid simulations now that get pretty close to actual water, which is crazy. But for the most part, if you're playing, I don't know, like some Ubisoft game or something, I don't know, yeah, any kind of video game. The way that water works is it's actually just a plane, like a flat thing like you guys were using for your ground. And then there's a shader on it that's causing the ground or the plane to ripple and move like this. And then there are different parameters through the code that are causing it to be like translucent, and you can change the colors and you can put textures on it then to make it look like it has foam, like the what kind of watery foam kind of stuff from an ocean. That's all in code, and it's all controlled by that concept, the shader. Okay. In Unity, the default for us right now, if you look at the material, right, we have this material here. I created this. We'll do this in just a second again. But there's a thing at the top that says shader, and it says standard. This will be our sort of default shader for a little bit. And then we'll start talking about, like other shaders you can use, which will open up other properties and other like different things that we want to play with. So for instance, if you do click on this like shader drop down and standard, you can go through here and you see a bunch of stuff, right? And if you click on mobile and you click on, I don't know, particles, right? And then additive, you see what happens here. Well, one, my ball disappeared. And two, it's like behind that thing. This looks really weird. It does some kind of cool stuff. Like it's rendering it behind the table, which is kind of neat. But anyways, it's doing really interesting things because it's completely different code, right? This mobile additive or particles additive shader code looks totally different than the standard shader in code. Okay. I'm not even showing you the code. Like if you do want to dive into that, I've linked in your homework assignment for 460 links to some amazing tutorials online with people that are, math folks, and it can explain this and walk you through it in a way that I just cannot. I took a couple classes in HLSL, and that's just enough to know like not to hurt myself. But if you do really get into that and you love like trigonometry and stuff, I mean, there's a lot of math, but it's really cool, like the magic that you can get and the sort of amazing stuff you can get from Shader. Okay, so that's a huge overarching discussion of visuals, right? So just to recap, and then I'll stop this video and then I'll start them and we'll sort of dive into individual components. But just to recap, right? If we're dealing with visuals in Unity, we have a mesh, which in this case, again, I'm clicking on this sphere over here, which is called the sphere. And that's a mesh. This one was from Unity, right? It's when you make a primitive. It's going to say sphere. If we happen to make like a 3D object cube, it's really big. Just be called cube, right? And if you bring in custom objects, as we'll talk about, they could be a lot of different things. It could be called, I don't know, cat or something. It's just the shape, right? That is used to show the shape of the object. It's also used to show the actual physical shape, which is then bringing in these ideas of collisions and colliders. And it's important also to know, like, you don't necessarily need this. You don't need a collider to have the shape, right? You could have an object in your scene with no collider on it, and that'd be totally fine. You could still see it, right? So I could remove this. Here's our cube, right? It's just got a mesh on it and just a mesh renderer. Looks like a cube. Has no physics, can't be interacted with. If you ran into this, you would just run right through it, right? It's like a ghost, but it's still visual. Happens all the time in games and sims, stuff off in the distance, you're never going to interact with. It's just meshes and that's it. Okay, so we have the mesh, right? On the mesh, we have a mesh renderer, and on that mesh renderer, we have our materials. This one, I don't know why this is called cube. I must have used this for something else. Uh-oh. Let me call this sphere. I double clicked on it and I did something. Okay, good, we're okay. It was called the sphere because this was confusing. Like it kept saying cube there, it didn't need to be. We have the sphere, and on that we have this sphere material, right? And this is governing a lot of different things. Within this, we can change the color. These are all the visual components. We can, on this, add textures. So we could put images on this. I'll show this in a different video when we play with materials. If you're watching these in order, it'll probably be the next one. But we could put images on there. We could manipulate those images. We can make the image, we can make the sphere translucent so it looks like, that's like a window or something like that, right? All of that is controlled on the material, and the code that is governing that, like what and how that works, is here. It's the shader. Okay. So you don't need to get into detail on shaders, though you're going to want to know what you're looking at, like if you're grabbing them from somewhere. And you want to know if you're interested in technical art, say you want to do the artist endorsement for Unity, like the artist certification, which I think would be great if you're interested in doing this for a job. That's a big part of it, is understanding that workflow, right? How do shaders work? Can you write some shaders? Do you understand like why and how sort of things function the way they do, right? Okay, so that's the overview. If you're in 460 this semester, we'll talk about this in class. Like this is really here to give you stuff to work on through the week. As this in 2022, this is the third week of class, and we've missed our first class because of Labor Day. So this is here to help you kind of bridge until next week, so you can make some progress on your little assignments that we're working on. So if you feel lost, it's totally fine. Always reach out to me if you have questions. I'm happy to chat about this in more detail. But these are here to kind of keep you moving so that when we get to class, we don't have to start from zero. Okay. Yeah, so renderers, right? Lots going on. Again, surface level stuff, totally fine. And in the next video, I'll start diving into the components a little bit more deeply so you can see the application as you can use it in your projects. Cool. If you have any questions, let me know. Otherwise, have a good day.